right. Well, let's get kicked off. Hello, everybody, and welcome to Phosphorus Live. This is our bi-weekly look at the very interesting world of xIoT, the extended Internet of Things. I'm your host, Mike Huckaby. I'm the head of go-to-market enablement here at Phosphorus, and I'm joined by our device-obsessed director of sales engineering, James McCarthy. How you doing, James?
Doing well. Howdy, everyone.
We're happy to have you join us. We get together like this every 2 weeks to provide some education on the connected devices that we all use to run our businesses on these days, and to give some insight into what Phosphorus does to help keep those devices secure. Format is simple: quick discussion on a specific topic, and then a Phosphorus technical take related to that topic. It's quick hit, less than 30 minutes, and we'll allow for some Q&A. And I have to say, excuse me, of course, I got a little crackly throat here today. But the topic for today is securing the workhorse of xIoT. But before we get into that, James, what's been happening at the xIoT news desk?
Yeah, big couple months here in the cybersecurity news world. The one that's most recent and that I've been seeing pop up a lot is just the nation state actors starting to understand and even start to leverage some of the default credentials in the industrial space, right? I think what we're seeing is a shift away from trying to be exotic when creating these kind of complex, multi-stage attacks against devices where you have to exploit one thing and then exploit another, and ultimately, working through that to get to your end goal. What we're seeing is people are just realizing more and more that none of that's going to matter if you can just log into a device with the default credentials. And we see some reports here about Iran actually recently, as a nation state actor, starting to leverage that a little bit more. In the last couple of months, we've seen some activity out of China where we actually saw a script that was written recently that literally had a full library of default credentials built into the script that they were using to go in at scale and check and log into all of these devices. So it was kind of a really big highlight on just how important the actual basics are of cybersecurity and the basics of hygiene, because you can have the most segmented network in the world and the latest version of firmware, and one default credential will undo all of that. So it is something we're starting to see an uptick in, and from a nation state standpoint, that's a little bit concerning, especially if you're in any of the critical infrastructure space, right? You've got PLCs that are controlling power delivery and other kind of life critical things, and default credentials can take all that down.
Yeah.
Fair. And that's that for the update for this week.
Cool. The interesting thing is one thing that we get to do, like in this show, is to breed awareness around that topic, especially with the default credentials. Of course, a couple of sessions ago when we did live hacking, so much of it was based on if I can get in with a default credential, then I can use the device as with the features that it's supposed to, except in a way that it's not supposed to be used. As we demonstrated. So again, it may, you might begin there and we'll describe in here in our sessions every once in a while of how we can, if you just log into it and you get the rights to log into it, there's a lot of things that you can do to disrupt automation, disrupt things happening, and on from there.
Yeah, absolutely.
Okay. All right. Well, let me just bring up my slides here and we'll jump in to our topic. All right. Do you see my slide?
Looks
there,
good.
James. All right, cool. Great. Yeah, as I said, the topic for today, securing the workhorse of xIoT, which is the PLC. But before we get into that, I wanted to, we use the term xIoT quite a bit here at Phosphorus. And I wanted to just give a little bit of an orientation for those who have heard the term, but aren't really sure what we mean by it, so that I can give a little bit of an insight into it. So it's the extended Internet of Things. We're looking at all of these embedded devices that are in here, all the devices that don't traditionally have a keyboard and a mouse. So Internet of Things, operational technology, industrial controls technology, Internet of Medical Things, all of those types of things that are purpose built, that have a very specific function inside of organizations, but that aren't typical IT. Very often, they aren't even managed or owned by IT. They're connected to networks, and they're interacted across the network. However, they're typically owned by different groups that are trying to work on a very specific purpose with that device. We think about things like medical devices, about infusion pumps, which we've talked about here, things that are in hospital rooms that are all connected, but are very specific devices towards keeping a patient healthy. Those types of things, purpose built. And all of these devices can't be treated like normal IT related assets in regards to securing them. Like, you can't put security agents on those devices. It would completely disrupt. They're not available or completely disrupt their operation. So those are the types of things that we talk about. As we use the term that's being used more and more in the industry around cyber physical systems, it's a kind of a broad term around it. But it's good to be able to understand that this is an all xIoT is an all-encompassing term around these embedded devices. And there's tons of things like it besides printers and cameras. There is, medical, like I said, infusion pumps, medical devices, robot arms, drones, whatever else you might pull into it, and PLCs, which is what we're going to talk about here the rest of the time. Anything you would add to that, what I just said about xIoT, the term of xIoT that we use, James?
No, I think the one thing, and a big part of why we use this term is, like you said, there's so many different things that it can represent. But what I find most interesting is when you start talking about PLCs or specific like OT, to a team that manages the OT. Oftentimes what happens is it's not just OT that's on their network or in their specific subset of the network, right? And it could be an IP camera sitting next to a PLC, and that IP camera is just as important as the PLC in that instance, right? And so that's why I think xIoT and trying to broaden the view of what we consider a protected asset for IoT is important, because it could be anything to anybody. Yeah.
One company does not have just one type of device. They have many different types, and managing these devices now, because they haven't been doing in the past, and being able to do it in an all-encompassing fashion, it's what's being required now.
Yeah, absolutely. Yeah.
All right, so let's talk about what is a PLC, a Programmable Logic Controller. So if you see here on the right side, we've got a picture that's actually in our lab in Nashville of the PLCs that we have on the wall that we interact with and we use in our demonstrations and in learning how to talk to those devices. They're a lot of times, especially today, small little control boxes that have a lot of smarts inside of it. Because whenever you search on Google now, you get the AI generated response. This is what Google AI said. What is a programmable logic controller? Small industrial computer that monitors and controls industrial equipment using custom programming. Doing things like monitoring the state of devices and the operation of devices, making sure that they're operating effectively and efficiently, automating tasks that go through those devices as well, and using it so that an organization can program specific devices. Like if you were to get a robot arm, the robot arm looks the same to 20 different organizations, but each one of those organizations, based on the way that they need to use it, will then program the PLC to make sure that robot arm works the way that they need it to work. And that gets into a very much more broad conversation. Variety of many different manufacturers across the board of types of PLCs, and I've got a few of them down here on the slide. But there are many more that build these types of controllers. So for those of you who don't know, like first PLC was created in 1968. And really, it was a way to go switch from hardwired relays in a factory to something that's programmable and flexible. And the programming side of it was based on ladder logic, kind of a different way of doing Boolean logic, but it was all based on the way the engineers at the time were used to the way that relay systems were deployed, and they looked at it in ladder. So ladder logic was built around how these things were programmable. It's still in use today. So over time, this little invention became what we call is the workhorse in factories. In the 90s, they started to be IP connected in the networks, and around 2000, we started to have personal computers and web-based interfaces to be able to get to those PLCs to start managing them and modify and program them. So today's manufacturers, they continue to focus at how do I make this controller, well, smaller with more features and more of an ability to automate controls in an environment? And in what ways can I today actually use AI as well to understand how the automation's working and to make better decisions on how to interact in that automation based on AI? So a lot of very, very cool things that this piece of technology that has been around since 1968 is doing today. And you can see them in every single vertical, from manufacturing to water treatment. We actually had a show just recently on water treatment plants, and we discussed one of the hacks, which was, there's two of them that we talked about. One of them was in Florida, where they accessed into a network and got to a PLC, and they were going to change the mix of chemicals going into the water. Now, they were discovered and stopped, but the idea is that that was a major target inside the PLC and the water treatment plants, because that's what those PLCs do. They monitor the water. They make sure that they put the right chemical doses in it, and then the pumping operations and making sure that those are all going through appropriately. We also talked about at the same time that there's a lot of PLCs that are actually out on the internet. And we had some water treatment plants that were actually affected because they were publicly available. You find these building automation and food processing. I was talking with a gentleman yesterday who's has a large background in food processing and using PLCs to make sure they're monitoring how ingredients are mixed together and that they're mixed together in the right proportions, the temperatures around how things are being stored and how things are being moved from one place to another. All of that is incredibly automated, all based on logic built in PLCs. Yeah, transportation, oil and gas. Oil and gas uses them for monitoring pressure around pipelines to make sure the temperature is right. You've got such volatile types of chemicals that might be coming through. You have to have a lot of controls and understanding of what's going on there. And people rely on PLCs to be able to control that. PLCs are used to run roller coasters, like right down the street from my house at SeaWorld. We've all of those big roller coasters there. PLCs are being used, and on, including robots. I had to mention robotic arms as well. Every single one needs to be moved in specific formats and ways, and those can all be programmed in by PLCs. So if that's the case, this little workhorse, this little piece of technology that is controlling so much, the potential for havoc by being able to disrupt their operation is quite great. So one of the things I wanted to kind of show is that, PLCs mostly used in factories and the like, but you know what? There's some fun usages of PLCs as well. I worked with a gentleman who prided himself on the complexity and I think overwhelming like joy that he brought to his neighborhood with the lights that he had at Christmas. And he had a PLC that he programmed to do all kinds of things. For one, turning them on and turning them off. But for certain times, if I could recognize that someone is coming up to the house, I could make patterns with the specific lights based on the person who's coming up to be able to do something different with the lights. And all of that's based on the programming that he put into his PLC. Heard of garage door automation, being able to recognize over time if something is still open, and whether it's, whether I've had an animal that's come in or a person that's walked in through the garage door and the sensors, and being able to then act appropriately depending upon that. So lots of fun there. I've seen a lot of appliances that are used, that are being controlled and monitored by using external PLC within somebody's house. And one of my favorite things that I found as I was researching this was smoker controls. Of course, using a PLC to be able to finely tune exactly how the smoker actually gets the right heat, and the right amount of time that's used inside of smoking your favorite meat, which I thought was kind of fun. So a lot of fun ways, maybe from our perspective, to be able to use PLCs. They're just not for manufacturing anymore. But if you're geeky enough, you can go find ways to be able to do that. Fun, huh, James?
I mean, smoking meat and controlling that with PLCs is
I
definitely
know, it's crazy.
right up my alley. Yeah.
Yeah, yeah, that's great. Well, then once you build one, then you can show me how you do it. So as we can say, PLCs are the target. So often in manufacturing, if I can get to a PLC, if I can change it in some way, then I can create great disruption. And some of these things, as I say, that the gateway to disruption here, quite often you get into environments where they're old and neglected. They don't know the state that they're on or haven't paid attention to them. So having visibility around what is actually there is a key thing, because we find this all the time, that things may not have been touched for 20 years. And you can understand why. If a PLC has been programmed for a purpose-built task that is very specialized for your business, disrupting the normal flow of operations, it could be very critical. So you don't want to mess with the PLC. So that right now, I would see that there are many organizations that are having to move forward by being able to change out PLCs, understand which ones are old, which ones have to be moved, and then also updating some of the programming that's in it. Most of the time, the programming that has been put into them nobody ever thought of these as being a security target when originally built. So most organizations weren't thinking or investing in secure programming inside of PLCs as well. PLCs inside of an environment also can touch so many other things. A PLC by itself is nothing. A PLC connected to HVAC systems, a PLC connected to power and lighting, to water systems. All of these things can become very critical. And they can also be connected to other PLCs. We find a lot of times that PLCs are nested in ways, one PLC connected to another. And imagine if you can get a top level PLC, it could be disruptive across multiple ways to be able to connect. So the focus ends up being understanding when an attacker comes in, they're going to be looking for the easiest way to be able to cause that disruption. And my example in the water treatment plant is that I can massage and manage so many parts of your function just by being able to get to that PLC. And so much that we focus on to be able to make sure that that we can keep those things secure. So going to that, kind of what are some of the basics then about securing PLCs? Well, I kind of mentioned this a couple of times. You have to understand what you have and also where they are. What are the PLCs that you're running? What are their purposes? And where are they in your environment so that you can make sure that you're making good decisions on it? Do I know how old they are? Do I know if they've been updated? Do I know when the last time I did any kind of code review on the programmatic side of it? Those are all things that need to be looked at. Promoting those secure coding practices, investing in the people that are creating the ladder logic in there to make sure that they're thinking security in the first place. Access control is got to be a key thing. If we talk a lot about segmentation in networks to make sure that they're hard to reach, but also just basic access control to the people who should be accessing them. The systems that should be accessing them, are they ones that are approved to do it? And credential management in PLCs becomes one of the most important things, especially as I showed before. We had so many PLCs that are publicly available on the internet. If you're not managing the credentials on those, then you just opened up your door wide open for somebody to be able to come in. It's important because most of the time PLCs have been very manufacturing focused. We haven't even thought of them as an IT or a security tool, in which case being able to have awareness for your security operations team that what the PLCs are doing and what they're doing and why they're a target is a key thing. I believe I see a lot of organizations that are building security organizations that are building IoT and OT practices. Half of what they're doing are just trying to educate traditional security teams on what it means to make sure that these types of devices like PLCs are secure. Got to make sure that the firmware is up to date, make sure that you understand what firmware it's on, and then keep that up to date in the best way that you can. And a lot of what hasn't been done well and has been done kind of infrequently is even just monitoring for state changes inside of those devices. The treatment plant in Florida was lucky that a person, discovered that there was a change in the dosage for the chemical. But if we could be building in a way to monitor those devices for state changes, when something is changing in a way that we weren't expect, and to be able to report back on that, that would be super important. Those are the other thing, that the big thing about making sure that we're keeping these things secure. Okay, so from here, James, why don't I hand it over to you, kind of talk a little bit more from a technical take, how we're securing, how we're looking at PLCs from a Phosphorus perspective.
Yeah, sure. I'll go through here real quickly and just show, for us, visibility is where everything starts. You have to know where your PLCs are. You have to know what you have in your environment. You have to understand that before you can do literally anything else to help secure your environment and to help protect your business operations. And for me, though, what I like to think about is visibility isn't just simply knowing where the devices are and what they are. Visibility includes the context of how is the device configured, how is it operational, and then also what is connected to that device downstream. And so when we talk about visibility, it's not just simply knowing where things are. It goes a lot deeper than that. I want to show a few things here to help illustrate that point, at least through the lens of Phosphorus. And so when we talk about PLCs, there's something that's a little bit unique to the world of manufacturing when it comes to how these devices can be connected to the network for two big reasons. One of those is they use oftentimes a lot of very proprietary protocols and speak in languages that aren't traditional TCP/IP networks. They're not standard protocols or ports that you would expect to see in even in an IoT space, because they're oftentimes created and maintained and owned by the manufacturer themselves, right? They want that proprietary effect because I'm sure there's business reasons, but also because they want full control over how these things talk on a network, right? And so things like a Rockwell, Allen Bradley PLC might leverage something called SIP, like CIP, which is a protocol that they leverage so that they can actually create these kind of secondary downstream networks, these private networks that they can use to connect PLCs to other PLCs. And so what happens is, if you're just looking at the kind of the entry level TCP/IP based network, and you're looking at it from a point on the network, or if you're monitoring for communication between that PLC and the rest of the network, you might only see that front line. You might only see that first PLC. And so for us to unlock the true visibility into an environment, you have to be able to see through that. You have to be able to talk SIP and understand what's downstream from that device. And you can see here, this is a great example of that. These are PLCs in our lab right now, configured in ways that we've kind of emulated customer configurations in their environments to try and kind of create that real world scenario. And you can see this is a Rockwell device. The IP address is a 192.168 address. We see that as that kind of first layer. It's sitting on the TCP/IP network. Everything's great, right? Very easy to identify. But that PLC has a network card attached to it. And that network card might actually have further devices connecting downstream on their own separate private network. And you can actually see that here. We have a gateway device that's got a completely separate IP address schema, right? This is running 10.200. And so if you weren't able to see through and talk through that initial PLC, you wouldn't have any idea that these things are connected downstream. And there are ways, there are native tools with Rockwell and some other things through like R-Link where you can talk to these PLCs. But talking to the PLC and getting it into that platform is in itself a manual process. And what we're saying is we need to help you identify where those things are and discover them first so that you know that you have to manage them, right? And so having that completeness of visibility is really important. The other kind of real concern with the PLCs here isn't just that they have their own potential subnetworks. It's also that they have a lot of detail around state that can actually matter to a significant degree, right? A camera's state in most cases is going to be on and off, right? Maybe there's a white balance setting that's specific to that device, but largely it's a binary thing, right? With a PLC, that's very different. A PLC can have a lot of different states for configuration, for run modes, for program mode. It can have a lot of other nuance. And what we find in the PLC world is that operational metrics and operational data can also be really helpful to understanding how a device is configured and how you might need to secure it, right? And so we like to bring in all of that data. When we connect to these devices and extract the content from inside of them, what we're trying to do is provide visibility to a whole nother level, right? Because it's not, again, just about the PLC itself and where it sits on the network. It's about the context of what the PLC is doing for you. And so being able to see the key switch position on that PLC, being able to see things like, is it online? How long has it been online? What devices are plugged into that PLC? You can enumerate the backplane of that device. And then again, seeing all of this visibility to the nth degree to get through that initial layer makes a huge difference when you're starting to think about what that can unlock for you later down the road when you start making decisions about how to segment your network or how to do that microsegmentation or how to isolate devices on the network, right? Being able to know that a PLC is falling in the right range and is configured correctly can really make a difference there. So all just in the world of PLCs and especially OT in general, there's a lot to consider. There's a lot of uniqueness about that space. And going back to what we talked about earlier with the concept of why we use the term xIoT, it's because this PLC sitting in the factory right now might have a camera sitting next to it. It might have a badge reader going into the substation that thing's actually deployed in. It might have any one of a number of other different, IP-enabled devices sitting around it that all kind of work together to create this business outcome of manufacturing, whatever that is, tractors or jeans or something, right? And so for us, it's not just about the PLC; it's about what's around it. Because if one of those things gets popped, so can other things as well. So that's
I like
Phosphorus.
to point out, and maybe you can kind of give a little bit of color on this too, James, is interacting with these devices. You have to understand the device and how the device talks so that you can get this good information out. So it's very important for us that we have learned how to be safe and efficient in this environment, because we understand as a company that they are incredibly critical to you as an organization to be able to make sure your operations continue to function. So we have to be able to be, again, safe and efficient in the way that we interact. Anything that you would add to that, James?
Yeah, just the criticality, right? When you're talking to a PLC, especially when that's deployed in a real environment, being able to talk to that device's native protocols and native languages makes all the difference in the world. It reduces that risk that you're going to cause an issue significantly, right? And so for us, being able to talk that language and be multi-language able makes all the difference in the world.
Yep. I have to say that I don't think there's, if I pound our chest a little bit, I don't think there's anybody more trusted as a security vendor in xIoT than Phosphorus at these days because of the way we interact. Great.
Absolutely.
Thank you so much for that, James. Thank you, everyone, for joining. We really appreciate you coming in. To leave you all today, I wanted to make sure that we are ready to come out there and be able to help you in your securing your xIoT estate journey. And as we've talked about in the past, we'd love to be able to have the chance to be able to show you how we can come in and discover all of your devices in 15 minutes, harden those devices in 30, and start helping you remediate issues on those devices in 60 minutes. We're here to be able to help. Again, thank you very much for joining. We'll be back again in 2 weeks. Looking forward to our Halloween topic in 2 weeks. But thanks, and everybody keep secure.